Hi, I'm Kelly Province, trainer for Sologen. In this video, I'm going to show you all the labels required in a PV system. And you can see in this line diagram, we have shown the locations of each one of these labels at the location that is required. There are a few other labels we'll cover, but these are predominantly the main ones. If we have multiple circuits sharing the same conduit, going through the same J boxes, combiner boxes, we need to identify them and separate them. And tagging is a very good way to do that. You can buy these from Hellerman Titan, and you can also buy these zip tie tags that are color coded. It makes it a very efficient way to identify them. Whenever we run our circuits, our source circuits, into buildings, we must have them in metal conduit. If we're on the building, we don't necessarily have to have it in metal conduit, but it should be. We see a lot of PVC conduit run on the surface of buildings. The bad thing about PVC is that it will sag over the years in heat. But whether you do metal on the outside or PVC on the outside, they all require identifying. Anytime you run a source circuit on a building or inside a building, up until you reach the first readily accessible disconnect, you must label it with photovoltaic power source. If you embed these cables into the roof rafters and this part is not underneath the PV array, then you actually have to go on the roof and identify this circuit, so that if first responders showed up to cut holes, they wouldn't be cutting through a DC circuit. So this has to be done at 10-foot intervals on the conduit, and the labels have a standard. We now meet the ANSI standard for labeling, and they have a height and a color requirement, and also they have to be durable over the lifetime of the system. So fading is not an option with these labels. The likelihood of you installing a bipolar inverter is pretty slim, but if you were to do this, there's a special label requiring the identity of this bipolar system. And if you're not familiar with the bipolar system, it's basically two separate PV systems tied into a single inverter, but one is grounded negative and one is grounded positive. And when they tie them together, they're essentially a series circuit, except they ground the positive and negative of one of each on the DC side, which brings it back to a parallel circuit. So if that ground were to be lost, we would have a high voltage, and this warning sign has to be put in place. Chances are you won't install one of these, so you may not have to worry. Ground fault detection. This is required on PV systems, so is arc fault protection. The label should be on the inverter, both the arc fault and the ground fault label, if it has it in the inverter itself, and I'm sure that it will. So verify that. If it doesn't, then you'll have to put that on yourself. Arc flash is something that occurs with high voltage and high current, so it's basically a commercial issue. If you have any location in a circuit where you can work on it live and you have direct access to touch the live parts, there must be an arc flash warning sticker on the face of the equipment, indicating the amount of heat, the calories per cubic centimeter, and identifying the type of clothing that is required if you get inside of this boundary where the temperature rises to the point where it could be damaging or fatal. Disconnecting means we are required to have disconnects on all PV system source circuits. So whether we have overcurrent devices or not, we have to have a disconnect. The label must say photovoltaic DC disconnect, and often we have this in conjunction with the label that I'm going to show on the next slide. So this has to be in a readily accessible location and visible and meet the ANSI standard for labor requirements and must be viable for the life of the PV system. Here we're showing another DC disconnect label, and this one has the operating current, operating voltage, max system voltage, and max system current on it. So this is standard test condition. The first two are standard test condition readings. The last two is the coldest day voltage, and the last one is the maximum current, which is ISC times 125%. For the AC side, microinverters located beneath the PV modules, which is where they typically are, they must have a disconnect. Of course they do. But it's a non-load rated disconnect. That being the case, there has to be another readily accessible AC disconnect located with a label on it stating where these inverters actually are. So it has to relate to the inverters that it's disconnecting. This warning label is only required where the terminals are actually accessible. This kind of goes along with the arc flash warning. If you can access these labels, whether it's residential or commercial, and work on them, you must have a label indicating that the terminals are live and may be energized. AC disconnect labels. So the AC disconnect must be in a readily accessible location. Believe it or not, inside of a home, as long as it's readily accessible inside the home, is considered readily accessible. Now the utility company won't recognize that. They will insist that it be placed outside where it should be. So more than likely this is going to be where you place it. Not only does it have to say AC disconnect, but it needs to also say state the operating voltage and the operating current. Another label that's required or possibly required on standalone systems or utility interactive systems is basically a plaque or a directional label that tells you where the AC disconnect is if it is not located where you think it should be. And where would you think it should be? If it's an off-grid system, it would be where you drive up to the house or the structure. If it's a grid interactive system, it's where the meter is. So if the AC disconnect is not located where the meter is, there should be a label or directory stating where it's located. It's a new requirement in the 2014 code for rapid shutdown. This is to maintain low voltage away from the PV array. The 2017 code is going to push it even closer to the PV array. Right now it's 10 feet from the PV array if it's on the exterior of the building, and 5 feet if it goes into the interior. So there actually has to be a contactor of some sort that would actually disengage all the conductors and reduce the voltage of the PV array. The nice thing is residential systems are usually either microinverters or PV optimizers, which do this for you automatically. So that AC disconnect becomes the rapid shutdown system. My recommendation is, even though that's not actually a rapid shutdown system by definition, you should have a label there, because this is for first responders. We want them to be safe, we want them to feel safe. So on that AC disconnect, if that is the mechanism that shuts down the PV system, place this label there as well. So back here on this disconnect, if that is the mechanism that shuts down the PV array at the array, and put this label on there as well. This is a label that goes right next to the breaker on the back-fed breaker into the panel. This is the inverter breaker. We place this at the opposite end of the main breaker to keep from overloading the bus bar. So this is a label that has to be on. People overlook this, ignore it, and don't install it. If I was an inspector, I'd go straight for the panel and look for it. So it needs to be there on next to that breaker, identifying it as the breaker that cannot be moved from that location. and here is the location of that breaker, and so when the cover is put on this panel, that label should be right next to this breaker, so it's clearly identified as the one that cannot be moved to a higher location in the bus bar. Well, that's essentially it. That's the key labels for PV systems. There are a few others, but they're not critical. These are the critical ones. So I hope this was helpful to you, and thank you very much.